If I stand right in the middle, it focuses first, and then I can step off to the side, and now it knows where I am, and won't be blurry for the first 2 minutes. Okay, so 71 you said? Mm-hmm. Let's also look, so remember so this will be section 5.1 recap. So this is not material you have to look at if you don't want to. So remember what we're talking about now is we're talking about doing antiderivatives. So derivatives, we've been doing that all semester. Now we're just going to move backwards. So it's kind of like multiplication moves one direction, division moves the other. Addition one way, subtraction the other. So we're really just kind of doing the undoing process. So let's actually look at a couple that were on a prep assignment. One of them was this one. I think that was 41. If we were looking to take the derivative of this, what's the first thing? Was this 45? If we were looking to take the derivative of this, what's the first thing we would do? Rewrite it. Same thing here. Okay, so with that same thing applies. So here, the first thing we want to do is rewrite it. Then now it's a power rule, right? So now we have power rules for antiderivatives. So we'll make a couple of rules here. So integration rules. So we have the power rule, exponential, log. Same rules we have for derivatives, we're going to have for antiderivatives. So the power rule, if you take the integral or the antiderivative of, remember for these, everything, this is the backwards operation to derivatives. So that means that where derivatives, we used to bring this multiply down in front, now we're going to divide. And where we used to bump the exponent down by 1, now we're going to raise it. So whatever you do with derivatives, you're going to do the opposite thing. So this would be raise the exponent. And that's what I usually do. When I'm doing it myself, I raise the exponent first, and then I know I need to divide by that. And we always add a plus c, because remember, any constant out here, when I go to do the derivative and go backwards, the derivative of the constant is 0, so any constant will work. So we don't know what that is, so we always put plus c. So coming back over here, this is in power rule form. So the first thing we'll do is raise the exponent by 1. So negative a half plus 1, positive a half. Now we need to divide by a half. Dividing by a half is the same as multiplying by 2. So here, anytime you've got fractions, I think about multiplying by the reciprocal as opposed to dividing. It means the same thing. So that would be 2 plus c. So anytime you have anything in the denominator, with the exception of, let's just look at it. Let's just look at these. They're all. So this one I rewrote as a power rule. This one I can rewrite as a power rule. And you'll get good at writing integral signs after a while. I've been writing them for a really long time. So again, this is a power rule. What about this one?
They go back to being a log.
This is a limit. And here's the problem. If I try and rewrite this as a power rule, and then I go to raise the exponent by 1 and divide by, does that make any sense at all? No. So if you try this route, you will get an answer that makes no sense whatsoever. So you know that this is not the right route. This is a log. So the integral of dx over x, or another way to write that is the integral of 1 over x dx. They mean the same thing, but this pattern is one that we want to recognize. Derivative of the denominator is in the numerator. This is just ln absolute value x plus c. And then for completeness, exponentials we love because derivative and integral, they're the same thing. So that's nice. Okay, so what was 71? That's what you really asked about.
Like derivative of an antiderivative.
Oh, yes.
So they cancel.
Yes. So number 71 was this. Derivative of the integral of
X cubed.
We're gonna make this number 71 embellished. You don't have to write all that out. That just looks really horrible, doesn't it? Except that this and this undo each other. So the answer is that. Okay, so derivatives and integrals undo each other. This says take the derivative of, the antiderivative of that. It's like saying take the square root of the square. That's another one. So these undo each other. So it doesn't, once you see this, it doesn't matter what else follows, that whole thing is the answer. It could be anything. So that's an important piece to remember. They undo each other. Okay, any other questions on the basic stuff? Okay, all right, let's go ahead.